Hello, everybody. Welcome to this webinar in pre-stress. My name is Flavio Popescu. I am a sales and support engineer at Strusoft. For those of you who are here for the first time, it's nice to meet you. Today, we are going to use GoToWebinar online platform. Here, you will have the option to ask questions. There is a question section in this GoToWebinar window. If you go there, you will see that you will have the option to ask, and you will ask by typing a question. Today, my colleague Pierre will be helping me with the written questions. So please, if during the presentation you have a question or you would like to see something, please type your question in the questions field, and we will make sure that we will answer your questions. If you have a microphone activated on your computer, you'll also be able to ask questions live. There is an option to raise your hand here and go to webinar. So at the end of the session, please raise your hand just like in school, and I will be able to see it and then give you microphone access so we can actually have a brief conversation. Today, we are going to take a look at Hollowcore design in pre-stress. Pre-stress has had a lot of new improvements and a lot of new functions implemented recently. And this makes it the perfect tool for designing Hollowcore slabs. So I have opened pre-stress and I'm going to start a new project. Every time I start a new project in pre-stress, I can select the national annex for my region. For now, I will choose the standard one. Here, I will enter the input data for my project. I will give it a name, and I will call it Webinar 101. I will give a length for my element, which will be 7 meters, and I have to choose my cross-section. For this specific topic, which is Hollowcore design, I have a very important feature, which is the import feature. Here, I can choose a CAD drawing, open it, and pre-stress will identify all of the sections that are in that file. So as you can see here, it has identified my Hollowcore profile. I can see here its properties and width, height, and I can use this directly from my AutoCAD file into pre-stress. Of course, it is also a very important step in the design process because it is very important to have a good cross-section as it will be imported and used further here. So just make sure that you have a good AutoCAD drawing, a consistent AutoCAD drawing. And I mean continuous lines and closed loops, just so it would identify it in the right way. But here I need to specify a name for it for my example, and I will use it a Hollowcore section, let's see, 265 as in height. And here I have to make sure that my units are set straight. So I will use millimeters. I just click import, and my section is ready to use. Just click OK. I also have the option to add structural topping, but for this example, I will not use any. So I'll just click add. Right here from the beginning, I am asked to create a default fire load combination according to the current code settings. And I will check that since I want to look at the fire effects as well. And I'll click OK. So my element has been created. The section has been imported from AutoCAD, and I'm ready to begin my calculations. First of all, I want to define my strands, my strand layout. I do this here in the main reinforcement tab. A very easy way to do it is to use the reinforcement pattern. Here, you can use reinforcement patterns, as you can see here in the picture. And you can save these patterns and use them in further projects, on other projects that you work on. And again, using this reinforcement pattern, it is very easy to position my pre-stressed strands. So I have this example here. I've already loaded a pattern for it. And I can just choose the positions for my strands and add them like that. And this is a particular usage for this is when you want to define different types of tendons, you can easily and very fast set up this material, for example, and let's say I want 9.3 millimeters there. And I can see that very easily I have created two different types of strands positioned symmetrically in my Hollowcore. So this is a very, very important feature, and it helps speed up the process and makes everything more smooth. What else I can do with my element here before I go any further is edit recesses and core fillings. Here in this window, I can see that I have the option to add core fillings. What I have to do is enter the ID of my core. Let's say I want core 2. I enter an X coordinate, and I can see here X, Y, and Z coordinates. So I want to start from X and end in, let's say, 700. I can also choose a material for my filling. So I'll just use that and then click Add. And I can see that the graphic representation has been updated, and I can see that for this section here, my core has been filled with the material that I chose. Right? I can also add recesses, which basically are holes in my element. So I enter the coordinates once again in the X direction. Everything is in millimeters here, so I'll say 3000. Y coordinate, I will say 300. And Z is the height. So I'll say a start coordinate of 0. And I'll give it a width, which would be 400. A height, which will be the height of my section, 265, and then a length of 600. Let's see where it's at. It sets it right there, and I can see that my element now has a recess and a filling. Okay, I'll settle with this arrangement. And I can notice here that I have several tabs. I have the reinforcement details tab where I can set up my bar details and set up the cover for my reinforcement. In the calculation settings, I have some specific settings for my Hollowcore elements. I can see that I can perform a punching check according to EN 1168. I can also do a splitting, spalling, and bursting check. I have this little information boxes here, which give me details of what these functions do. In the shear calculation settings, I can choose actually a method for web shear failure. I have 3 different methods here, the standard Eurocode 2 and the advanced EN 1168, which is specifically for Hollowcore products. So I have the option to design it and check it here, according to this EN 1168. I'll just use the Eurocode 2 for now. And I move forward with the tabs. I go to the fire tab, and here I see I can set up my fire time, let's say 60 minutes from the bottom side, and different settings for aggregates and reinforcement. In the calculation sections, I can set up my sections where the calculations will be performed, and I have some default sections already made, which of course I can delete and create my own. Okay. For now, I have this element created with some strands, some core fillings, some recesses. I have set up a fire calculation. It is time to look at the loads. If I take a look here at this tree system, I can see here the load combinations and load according to the construction stages for my element. So I have all the stages from release up to a final stage in the ultimate limit state and a fire combination, which has been generated automatically. What I want to do is create some more load cases. For that, I go here to input loads, and I see that my self-weight of the structure has been already created. It is clear to see that the filling here has created some extra self-weight, and also the hole here has reduced it. So this is generated automatically, so I don't have to worry about that, which is great. What I want to do is create some more load cases. Let's say I have screed loading from screed, and this is a permanent load, and I'll add it here. And I'll have some office load and just choose the type here. This type here is important to select because you will see in a second the load combinations will be generated automatically according to the types. The coefficients will be chosen automatically according to these types when creating load combinations. So let's say I'm going to use these types, and I'm going to actually add some loads for these load cases. For the screed, let's start the screed, which is a permanent load. I will have a uniform load here. I'll have a 1.2 kilonewton per meter, and I will add it from this direction phase. It is possible to add uniform loads and point loads to my element, and also trapezoid loads. Okay, I have some screed. Then I have the office load, which I also want as a uniform load. It's 2.4 kilonewton per meter. And I will add it from the intermediate stage here. For the final stage, I will enter a eccentricity. It is also possible to add eccentricities to your loads. So if I say here 0.3 meters and add it, it will have an eccentricity of 0.3 meters from the centroid. I can see that here. I can see that I have a eccentricity from the centroid of 0.3 meters and the load is applied there. This is useful to represent walls, for example, loads from walls. It could be a facade wall on this end slab, for example. It could be an end slab and there's a facade wall there. So it's nice to represent that. It's easy to represent that. And I can also add actually a point load. Yes, I'm here. I will say 10 kilonewton. This is a length from the left edge here. I can say, let's see, 2 meters. Let's add it with eccentricity as well. 3. And the B here, which is actually the plate where with this force will be distributed. So if I say here 0.3 meters and add it here, I can see this load with an eccentricity, and this point will have a distribution length here of 0.3 meters. This is what the B is. It is for the punching checking. As I have chosen and had the chance to do a punching check, I will do it with this force, point force, with the length of 0.3 meter in distribution here. Also have the option to enter this eccentricity from the left end or from the right and mid top beam. But I will use it like this as a centroid. And I want to add it for fire too. Just enter another uniform load like that. Okay. Okay, so I have some loads. If I go to load combinations here, while in the loads, input loads, I can see an overview of all my loads, which is nice because it allows me to see if I have added everything I need and where I need it. So once I have added these loads, I can actually generate some load combinations. If I go to my load combinations here, I can choose each stage and add load cases to it. What is new in pre-stress is the automatic generation of load combinations. So what this means is if I go to erection here, and then I just choose my loads, the coefficients will be added automatically. In this case, it was just 1. But if I go to intermediate stage and I just click on these, you can see that the coefficient has been added automatically. And I just have to click change. So again, this helps me make the load combinations really fast. And just need to select the load cases specific for that load combination. And I'm done with defining my load combinations with the right coefficients from the National Annex. One more thing that is relevant here is the long-term parameters, which I can enter. I have the creep coefficient and the shrinkage, which I can enter here to be considered in my calculation. Once I have this, I am ready to perform a calculation. So I go to Calculate tab, Analysis, and just click Analyze. This will generate some internal forces and deformations. So let's see what I get. I'm going to remind you again that you can type in your questions at any time here in the Questions tab and go to Webinar. My colleague Pierre is here to help with these questions. Okay, so I have some results now. I have here the bending moment. I have torsion. I have axial shear force here. And I also have axial force if I have any axial forces, and deflection. So I see here an overview of my results at different stages. I also have these results in table format. I can see the reactions, for example. And I can see them in this way, in this table format. Yeah, I have different types of results here in table format for my load combinations. What I want to do is do a design now. If I go to Calculate Code Control, and depending on the number of sections that I have, calculation sections, it will take some time. Of course, the more sections there are, the more time it takes. But then I get a nice utilization here for my element in the different stages. This graphical utilization is good because I can see actually the behavior here where my hole is. So I get this distribution of the utilization, and then I have my results here. I have the code check where I can see all the checks that have been performed for each of my stage. You see here that for the release and SLS combinations, I have stress verifications, and then for my final stages in the ultimate limit state, I have the moment capacity, shear capacity, and punction check, since I've selected that. Then I have the fire with their moment capacity, shear capacity, exposed to fire. I also have the table for bending, again, for all of my stages. In the release stage, I can see here it checks for cracking as well. Crack stage 1 means that it's uncracked. So it's uncracked so far. I can also see the stresses in the concrete and in the steel for each of my section. Whereas if I check my final stages, I have the moment capacity and moment utilization. Some other results that I want to see is the fire reduced concrete parameters. So here I get a table with my reduced concrete parameters exposed to fire. And also for the reinforcement, another result is the temperature gradient for my section. I get a distribution of the temperature here in this gradient representation. I can also see a damaged zone area. What is outside of this zone is considered damaged. So temperature is above 500 degrees. So the concrete is just considered destroyed. The punching check is performed as well. I can see it here for my final stage. And spalling. All of these results are gathered together in a documentation report. If I go to printout, I can select a section for my fire calculation. And the program will generate a documentation report for me with all the results, all the input data in this PDF file. Which I can also edit and set up the description and project file and company name in my settings. can see there are already some questions, and Pierre has answered them here. At the end of the webinar, we will send out all these questions with their answers via email. But just to address one of them, which I think is a good one and helps me remember what I want to show, is the shrinkage and creep and shrinkage calculator. We have actually a concrete creep and shrinkage calculator from Strusoft. It's an online tool which can be accessed at any time. It's this website here, webpage, and you can type in your concrete properties, enter them, and then get the creep and the shrinkage parameters. You get these, which you can copy and then paste in pre-stress for your long-term calculations and verifications. Okay, I think I saw someone raise their hand. Let me see if that is still available. Yes. Aurel, hello. I will grant you the microphone for a second. Can you hear me? It is, yeah, it could be that you just clicked it by accident, but I just thought I'd see if you have a question and want to talk about it. If so, just make sure that your microphone is connected to the computer, because right now I can't hear you. That is what I wanted to show you today. If you have any further questions, you can address them here in the questions, or of course at any time after a webinar, you can just drop me an email or just give me a call and we can have a chat. I'm available at this email address and this cell phone number, Danish phone number. If I know there are a lot of people who are using the pre-stress tool right now. It's really nice, and I'm really curious to know how you use it. But if you don't have it yet, you can apply for a trial here and test it for yourself. If you go to strusoft.com products pre-stress, click on Get Started Now. And here you have a trial license. Fill out the form with your name, company, and email address, and then submit. And you will get a trial with full options for pre-stress. So you can see it on an actual example on one of your Hollowcores. Since we're talking about Hollowcores today. Okay, if there are no more questions, then I will say thank you for today. Okay, just got one more from Ian. Okay, Ian. Thanks for your question. I just showed you, I guess. Didn't say anything. I was waiting for Pierre maybe to type something, but it is really easy. Okay. Thank you so much for attending, and good luck on your Hollowcore calculations. Have a great day. Bye-bye.